Hi there. My name is Christina Henry, and I work as a forensic scientist, or my title at my laboratory is criminalist. And I work at the Santa Clara County Crime Laboratory out in California, in San Jose. So I was asked to talk to you guys about what I do and how I got my job. So I got my job, my education is chemistry. So I have a chemistry degree because I enjoyed science and stuff like that. And when I went to try and figure out what I would want to do with it, I thought, well, I like forensic stuff. So I got a job that way. And what I did was I sent my resume out to lots of crime laboratories and uh, I filled out a lot of applications. It was not easy to get a job in this field because it's a highly competitive field, but there are jobs to still be had. My background, like I say, is chemistry, but there are people here who have biology degrees or forensic science degrees. Forensic science degrees were very rare when I was going to school, but right now they're very common. There are a lot of schools that offer forensic science degrees. So if this would interest you, pursuing science, particularly chemistry or biology, would be a very good way to get into a field like this. And then maybe in college, you go for either a chemistry, biology, or forensic science degree. Because my background is chemistry, the things I do tend to be in the chemistry area. So one of the things that I've done in the past, I don't currently do this, but I would analyze drug cases. And so this is where I look at a white powder and tell you whether it's a drug or not. Currently, however, my main job is I look at evidence from fires that they find suspicious, and I will look at the debris that's left over after the fire, and my analysis can tell them whether or not an ignitable liquid was used or a flammable liquid, right? So something like gasoline or lighter fluid. So I can tell them that gasoline was at this fire. And that would help them potentially say, oh, well, then it's probably an arson. I don't say it's arson, that's up to somebody else to decide, but that's what I do. Other things I do, that's my main purpose, but what I also will do is I'll look at other types of chemistry analysis. So I'll do poisons or other things like that. One of my most interesting cases that I ever did was a few years ago where there was a woman who was acting very suspicious at a Starbucks. And she was messing around with the orange juice containers. And one of the people at Starbucks, one of the workers, one of the employees, saw her and like approached her, and she kind of ran away. And then they picked up the containers that she was messing with and said, "Oh, these are warm and they smell weird." So they called the fire department and 911, and they came out and they looked at what was there using their instrumentation, and they thought it was something really bad. Well, they don't have very refined instrumentation like I do, so they brought it to me, and I took samples and I figured out how to do what I was doing. There was no poison in this, but what it was vinegar. And I was able to, my first instinct was that it was vinegar based on that it smelled like vinegar, but then I had to develop a method on how to figure out whether or not it really was vinegar. And in that particular case, it was. And she wasn't charged with food tampering or anything, but she did add, assuming that she was responsible for this, vinegar had been added to these juices, and they were like expired, so they weren't even like the same juices that they had in the container in the cooler. So it was very suspicious. But like I say, she was not charged, so that's kind of how things are. But I've done other cases. I had another interesting case I did where there was, because I do the fire stuff, one of my fire investigators was asking me one day, and he said, well, so we've had this incident where this gardener at this house. Uh, he was doing the weed trimming, and he hit a rock, and the rock exploded, and he got burns on his legs. And they were worried because, and I don't know if you guys ever heard about San Bruno, but it was a huge gas explosion that caused fires that damaged many, many houses. And uh, that was something that they were worried about because it's like, could this be another natural gas explosion where maybe there was a gas line and there was a leak, and that's what happened. So they had the gas people come out and they checked, and the gas line was nowhere near it. They checked the soil and they said, no, the soil has terpenes in it. So my investigator, he asks me, because he knew what terpenes were, and terpenes are basically in turpentine. And he said, so their theory was that the terpenes come from wood, right? So their theory was that there was like rotting wood in the soil that had like developed these terpenes. Maybe there was a pocket of gaseous terpenes, and when he hit the rock, it like sparked, and it created like the pocket opened and terpene gas came out, and it exploded. And he asked me, is this plausible? And I said, no, because if that were, trees would blow up all over town. That doesn't happen. So he asked me, would I be willing to look at the soil myself and test it? And I said, of course. So he brought it in and we tested it. And what I found was not terpenes. Well, I found terpenes, but that wasn't what was interesting about it. What I actually found that was interesting was a chemical called TATP, which is otherwise known as triacetone triperoxide. Now, this particular chemical is highly explosive. In fact, terrorists use this chemical because it's very easy to make. I'm not going to tell you how to make it, but it doesn't take much. Like it can be made with common chemicals that people have around the house even, but it's highly explosive, and just like touching it can make it explode. So the terrorists who use it often don't survive because it doesn't make it. So they don't use it as often as they used to. But I found this chemical. And when I told my fire investigator about it, he asked me, would it be possible that this could have been made by accident? Because again, it's made with common chemicals. What if this was a dumping site and like for years someone was dumping chemicals here? Would it potentially be something that could create by itself? And I said, not really, because the chemicals involved are all very unstable, and so they would have evaporated or broken down over time. There's no way this could have been there for very long. Also, the resulting chemical, the TATP itself, breaks down, is highly, like it's highly explosive, etc. So I told him what's more likely is somebody disposed of some TATP in this area at some point, probably relatively recently. And when the gardener went by, he did, hit that rock, hit a spark, and it ignited the TATP. My investigator wasn't thrilled about that answer because he's like, but the lady who lives there is like 90 years old. I don't think she's doing it. It's probably one of her neighbors, but with no way of tracking back who could have dumped something there really wasn't much he could do about it. So those were a couple of my interesting cases. I also go to crime scenes, and I've gone to a number of crime scenes. I won't tell you about any of those because they tend to be a bit gruesome, but those are sort of the sorts of things I do. So like I do these cases where I'm looking at chemicals, I go to crime scenes, and the other things that we do here at the lab that I don't necessarily do is we look at DNA. So, a crime scene, we could look at whose DNA is this? Is the blood stain on the suspect's shirt, does that belong to the victim? We do that. We look at latent print processing. So, if somebody left a fingerprint at the scene, we can say, okay, it's this guy's fingerprint. Actually, we don't say that part, but we will develop it so that someone else can say that. We do computer forensics, where we can look at somebody's cell phone or computer and find out what they searched for. Just as a fun fact, if you Google something, that gets stored in your computer, and even if you erase your history and stuff, the computer forensic guys can still find that information. We do toxicology. That's looking into somebody's blood to see if they have drugs or poison or whatever in them. And we also do firearms testing, so they can look at a bullet at a crime scene and compare it to a bullet fired from a gun that they found on the suspect's body or house or whatever. And they can say, yes, this bullet came from this gun. So we have all of these sorts of things that we can do. Personally, I really enjoy my job, and if it's something that would interest you, like I say, the best way to go into it, and if you watch CSI or NCIS or whatever, you kind of get an idea of what I do, but it's not exactly what I do. But if you watch Forensic Files or some of the more true crime stuff, it's a better idea of what we do. But the reality is that we don't go to crime scenes that often. Most of what we do is in the crime lab. Most of what we do is like what I was describing. So if that would interest you, your best way to pursue it is to go down the science path of chemistry or biology or forensic science. But if more true crime stuff like the detective stuff interests you, that's more what the police officers do. So the police officers, they follow a completely different path. If science isn't your thing, but this would be interesting, you might look into going that way, becoming a police officer, or maybe even an attorney who prosecutes it. So, but that's what I do. Hopefully this was interesting for you. And I'm sure if you had any questions, unfortunately I'm not here. But if you have any questions and you ask your teacher, she can forward those to me, and I might be able to provide you some answers. So hopefully this was enlightening to you, and I wish you good luck in all of your future endeavors. Thank you.